Question number 1, asking generically for an antiderivative, and the first thing we should always ask is, can we simplify? And I think, yes, I think we need to FOIL, right? So we're really saying we've got x cubed plus 2 times x cubed plus 2 dx. So let's see, we've got x to the 6th plus 4x cubed plus 4, which I don't even need to write it down, I see it. I get a 1/7 x to the 7th plus 4x to the 4th over 4 plus 4x plus c. So I love that this is a great reminder that sometimes it's a simple FOIL it. Obviously they're putting a lot of options in here for you to kind of like get tricked by. Don't lose sight of the fact the first thing you should do is try to change the way it's written. All right, number 2, don't lose that 4 out in front. That would be easy to do. But just like number 1, can you simplify? And absolutely, right? It's a big deal. We can't have quotients or products, so we have to get rid of them. So I have a 4, I'll leave that there. And then I have a 1 over x minus x. We're going from 1 to e squared, which is kind of a funny looking one, isn't it? Doesn't matter. So let's see, the antiderivative of 1 over x is the natural log of the absolute value of x. And then the antiderivative of that x is a 1/2 x squared. I'm still going to multiply my answer by 4, and I'm going to integrate from 1 to e squared. So again, there's that 4 out in front. So I've got the natural log of e squared, which is 2, minus 1/2 e to the 4th, parentheses, minus the natural log of 1 is 0, minus 1/2. And we're just going to clean that up. So, my gosh, I don't know why I was writing so big. I am really out of room. But I've got a 2 plus 1/2, which is a 5/2, and then a minus 1/2 e to the 4th. So what does that give us? 10 minus 2e to the 4th, which is letter E. Good. All right, now I bled into all of our room here for number 3. Number 3, we could do a couple of different ways, but I'm going to start by writing it as the integral from 3 to 11 of 2x plus 3 to the negative 1/2. I don't mind rewriting it this way. Yes, it's a composition, but the inside is a linear function, so we're allowed to reverse the chain rule. So that's what I'm going to do. So I'm going to add 1 to the exponent, divide by 1/2. That's to finish the power rule. The chain rule says divide by 2. So I really have the square root of 2x plus 3 evaluated from 3 to 11. So let's see, we have the square root of 25 minus the square root of 9, and that's where we get our 2 from. All right. So now we get into something like number 4. They just flat out tell us to use substitution, which I think is fantastic. If u equals x plus 1, well, then maybe we should go ahead and say, well, then du dx equals 1, which means du equals dx. So let's go put everything in the puzzle here. So I have the integral of x, come back to that, all over the square root of u, and then dx gets replaced with du. Remember, the whole goal with substitution is to completely, I know we haven't reviewed a straightforward substitution question, but is to completely translate from x's to u's. And I've not done that. I still have this x. So that's okay. We'll go back here and subtract 1. So now we have u minus 1 over radical u times du. We're still not done. We still don't see that here. However, at least now we can draw our heart and simplify that. Now, they did not ask us to take the antiderivative. They just asked us to find an equivalent expression. And so that's where we get letter C from, option C, if you will. Okay, kind of a tricky little thing in there. We saw one of those in our homework. All right, let's take a look at 5. Now, 5 is a quotient, not unlike number 2. And when we were talking about number 2, we said, well, we can simplify it. I can't simplify this. I can't split it up. I don't have any I don't have any like trig identities I want to use, nor do I really want to pull out anything anyways. This is a great case for substitution because I see sines and cosines. I love that. So when we did substitution, we said pick what's inside parentheses, what's inside a radical, what's inside an exponent. In this case, I don't have any of those, but I'm going to pick what's in the denominator. So we pick our u, we take the derivative of u, and then we solve for dx. I didn't leave myself a lot of room to do that. Picked the u, took the derivative of u, solve for dx. This right here is going to go in for this. This right here we're going to call u. We're going to leave our bounds off. Come back to those in a minute. But this is exactly what we wanted to have happen, isn't it? We wanted the sine x on top and bottom to go away. So I am left with a negative 1 over u du. And now we need to change our bounds. These were x's. And I need to go change them into u's. So I'm going to plug in the negative pi. The cosine of negative pi is negative 1. So my lower bound is now a 1. Cosine of 0 is 1. 2 plus 1 is 3. Oh my gosh, so sorry. And now we're ready to finish. The antiderivative is negative natural log of the absolute value of u from 1 to 3. So plug in the 3 to get negative natural log of 3 minus, and when I plugged in the 1, I had a negative natural log of 1, which is 0. And so that's where we get answer A from. All right, let's talk about number 6. Similar to 4 and 5, we have a product. And not only do we have a product, but we have a composition. We have a quadratic inside a square root, which is not okay. That's all right. We're going to use a substitution. So I'm going to pick what's inside the square root. So I'm doing those same 3 steps. I picked the u, taken the derivative of u, and I'm going to solve for dx. All right, so let's go back to our integral. We had that x. We'll have the square root of u, and then dx is du divided by 2x, which is great. So I'm going to slide that 2 out in front, right? So 1/2. And I'm left with u to the 1/2 du. The whole point of substitution is to get to a point where there is no product, there is no quotient, there is no composition. It should be a parent function, essentially. All right, so we've got that 1/2 from that constant out in front. I'm going to add 1 to the exponent to get u to the 3/2, and then I need to divide by 3/2, which is the same as multiplying by 2/3. And then a big old plus c at the end. Good news is multiple choice. We were never going to forget the plus c because they're in everything. So what are we left with? We're left with a 1/3 u to the 3/2 plus c. And what was u? X squared plus 1. So I think we're looking at letter C if I matched that up right. All right. So take a look at 7. 7, just like 4, 5, 6, even number 2, quotient, right? We keep saying no products, no quotients, no compositions. So I'm like, well, I got to get rid of the quotient. So I could try to factor, and if it factored, great. If I could reduce, even better. But I can't. So what we don't want to forget is that long division or synthetic division is a very valid method in changing the way the integrand looks. Which means this turns into x squared, I'm sorry, x minus 3, sorry, I should just rewrite it, plus 1 over x plus 2. I just changed my integrand because now I took one fraction and turned it into 3 very simple terms. So now I can take the antiderivative to get x squared over 2 minus 3x plus the natural log of the absolute value of x plus 2. And we are going to evaluate that from 1 to 2. So let's start with the 2. Let's see, I get 2 minus 6 plus the natural log of 4 minus 1/2 minus 3 plus the natural log of 3. All right, let's see where that puts us here. So I have a negative 4 plus 3, negative 1 minus 1. So I have a negative 3/2. I'm going to check that. I have a natural log of 4 minus a natural log of 3. And it looks like they combined that into the natural log of 4/3. Woo! Great time to review. Oh gosh. Great time, sorry, I didn't mean to do that. Great time to review that long division, synthetic division is a valid option for changing the way your integrand looks if necessary. All right, let's talk about 8. 8's similar in nature. It's a quotient. It's not as long as the one above, but we need to get rid of it. So we ask, can we use substitution? I'm going, I don't think so. We're looking like, can we factor? Can we reduce? Can we draw a heart and simplify it? And no, the answer is no. So I'm going to use long division again. Or to be honest, one option, not a great option, is to take the derivatives of all of these and see if you can get them to match that. I actually think that's a lot of work. So I'm going to do a little bit of division. Now, you cannot use synthetic division here because of the 2 in front. If you want, you can take out the 2. Right? Take the 2 out of the top and the bottom, and then you can use synthetic division. So you have a 6x squared, a 0x, and a 0. It feels silly to use synthetic division for this, but it works. So we multiply, we add, we multiply. What am I doing here to get positive 3/2, and we add, that's my remainder. So in my integral, I have a 6x minus 3 plus 3/2 over x plus 1/2. That's not the antiderivative, but at least I can now kind of take a look and say, well, I mean, thinking it's looking like it's going to have 3 terms. So let's see, 6x squared, so 3x squared, a minus 3x, okay, great, that's not helpful, plus 3/2 times the, okay, I don't love this because it's not going to match. Easy, easy fix. Multiply the top and the bottom by 2 before you take the antiderivative, and that'll fix it for you. So now you're just going to have a 3 natural log of 2x plus 1. So again, because it's multiple choice, we don't finish everything. We're kind of just looking at pieces along the way. That's horrible. I'm so sorry. But I cleaned up my fractions in there. I think that's a hard one to identify that we should have been using long division. All right, last question, number 9. Yikes. It's the same kind of like 7 and 8. We've got a quotient. We can't just take the whole thing and raise it to the negative first because that would be a composition that we can't undo. So another option, and by the way, when I see this is kind of like a, okay. I know I'm going to rule this one out right away because I just know the person who wrote this question is just saying, what if they accidentally just took the antiderivative? Like, that's not it. Okay. Also, I know it's not this one because, well, chain rule would say we'd have something else in there. We're going to complete the square in the denominator. So I have an x squared plus 4x plus 5. I just kind of gave myself some extra room. Let's use a red pen here. So what do I want to add? And then turn around and subtract in the denominator. Half of 4 is 2. Square it to get a 4. So I add a 4, turn around and subtract a 4. This factors into x plus 2 squared. Combine your like terms to get a plus 1 at the end. Now don't forget that's still in the denominator. That's one of the things I see happen most often. But at least I think now we're in a better place to say, oh, look at that, yeah. Arctangent, the derivative of inverse tangent is 1 over blank squared plus 1. So I get it, like that's kind of like, gosh, I never would have remembered to do that, but it is on our list of things to try.